Hello everyone, this is Dikumana Natasha from Group 2 and I'm with my colleagues Jean d'Amour, Cédric, Clémence, Achille Papi and Gato Robert. As you can see, this is the table of contents of what we are going to talk about, including the introduction to evaporation process, concept of evaporation, process of evaporation, concepts. Let's rush and go to evaporation. Evaporation is a process by which water changes from liquid state to gaseous state. It occurs naturally in various environments, including water bodies of water like lakes, river, moisture. As you can see, this is the concept of evaporation. Uh, the concept of evaporation starts from the sun, where the sun hits the water body, and these water bodies gain the energy. This energy that they gain led to evaporation. This water evaporates as vapors and go into the air. After that, they condense, becoming the clouds. Those clouds are the ones that precipitate and give the rain. And also, this process is continuously. As you see, this is the process of evaporation. As I was saying, and the last slide, the process of evaporation goes like heat absorption. This is when the sunshine on the body and on a body of a water, like lakes, rivers, oceans, the water absorb heat energy from the sun, as that diagram was showing us. And after this process, there is the process of molecular movement. As the water molecules gain energy, they move faster and become more kinetic. This becoming more kinetic, some of these molecules at the surface gain enough energy to escape from the liquid phase to become vapors, and as the result of going up as the vapors, and that was the concept of evaporation.
My name is Jean d'Amour. I'm also a member of this group too. I'm continuing to discuss about the process of evaporation. So you've seen that the second step is the movement of water molecules. After the movement of water molecules, the third step is escape to the atmosphere. So this is where vaporized water molecules rise into the atmosphere. This is where the process of evaporation occurs not only from water bodies but also from moisture, soil, plants, and even our skin. So this is where water molecules, after gaining energy, they start to vaporize or to become air structured. So after becoming vapor, they rise into the atmosphere. So the fourth step is the cooling effect. Interestingly, here we can see that evaporation has a cooling effect on the remaining water. By how? This is what happened as a result of the high energy molecules when the water molecules are living up. the average kinetic energy of the remaining molecules decreases. So after decreasing of the kinetic energy of the remaining molecules, it results in a slight cooling of the water surface. So the remaining water surface become more cool. Okay, after this process, we are going to continue with the measurements of evaporation. So evaporation is measured by using different measurements. Here we are going to discuss about some of them, which start with a class A pan evaporation. So measuring evaporation can be done using different methods depending on the scale. So we use different methods according to the scale and accuracy required. So here we are going to discuss about some common techniques used. The first one is class A pan evaporation. This method involves measuring the amount of water lost from standard sized pan placed in an open area over a specific period. The difference in the water level before and after evaporation provides an estimate of evaporation rates. So this is a simple way where everyone can use it to measure the evaporation. Is require only placing water in a pan or any other measurement, and you record the starting time, and you come after some minutes to measure what amount remained. So you can see when the water you remained in your instrument has reduced. So you can see that there occurred evaporation in that instrument where you put your water. So this is called class A pan evaporation. Class A pan evaporation is a standardized method. It's used for measuring evaporation rate as I've said before in different location. To me that you can use this method from one location and go to other place and use it to measure where in these two places where evaporation rate is high or low compared to other place. So it consists of flow, white steel cylinder with specific dimension. So internal diameter, these are measurements required. And the pan is filled to depth of 20 centimeter each morning. So these are amount of water put in your pan, and the depth of water the following morning before fill indicates the amount of evaporation loss. To me that if you put in water and come after another day, you can see that the amount of water is getting lost. So after filling at amount, you can see amount of water that lost. So its industry application, this class A pan evaporation is measurement used in industries. This require water supply management. So in water supply management in industries, we use this method of class A vapor evaporation. So it can be used also in industries for hydrological research, wastewater management, mining water storage, and evaporative mineral or correction industries. So features of this method: it is built to survive harsh environment. So it means that it resists to the unpredictable or so bad environment. So the stainless steel construction, to me that tools used in this method are stainless steel. So it means US's Australian standards designed to limit vegetation and fauna increase is to assemble and maintain, and it includes automatic fill system. So its also main feature is its long operating life. It works over a long time. So in detail, Class A evaporation pan is designed to provide accurate and reliable measurement of evaporation rate. So it is equipped with highly sensitive water level sensor and automatic fill system that ensures consistent operation. Comparison of this method with other methods. So evaporation from Class A pan can be compared with other methods such as pan evaporation and rock evaporation. Each method has its unique characteristics and application based on factors like air, temperature, relative humidity, and applications based on factors like air, others, and solar radiation absorbed by the water body. Measurement. Other measurement after Class A water evaporation is the gravimetric method. This is by weighing a container of water regularly and tracking the weight loss time. Here we measure the weight loss over the time. So researchers can calculate rate of evaporation also using this gravimetric method. This method is crucial in various industries such as water quality testing, environmental analysis, chemical manufacturing, pharmaceuticals, medical device, and electronic.
Hello, my name is Byiringiro Gato Robert. I'm a member of Group 2. I'm going to continue with the explanation of gravimetric analysis. Gravimetric analysis involves evaporating the organic solvent containing the material of interest and then measuring the residue left behind using highly sensitive balance. The difference in weight before and after evaporation gives the amount of non-volatile residue present in the sample. This method relies on accurate weighing techniques to measure very small quantities of residue effectively. Procedure for gravimetric analysis. There is first one is sample preparation. The sample containing the non-volatile matter is dissolved in a suitable solvent. Evaporation is the second procedure. The solution is heated to evaporate the volatile solvent, leaving behind the non-volatile residue. The third procedure is weighing. Weighing the residue is carefully weighed using a precise analytical balance. Circulation is the fourth procedure. The difference in weight before and after evaporation is calculated to determine the amount of non-volatile matter present in the sample. We are going to talk about the importance of accurate weighing. Accurate weighing is critical in gravimetric analysis as it involves measuring tiny amounts of residue. A high precision balance with readability up to 10 or 1 micrograms is typically required for this purpose. Precise weighing ensures reliable results, and it helps in determining the purity of solvents, assessing cleanliness levels, and maintaining product quality standards. Some of the applications of gravimetric analysis. The first one is ensuring cleanliness, medical equipment, and implantable devices. The second is minimizing microcontamination on electronic components like hard disk drives. Assessing product quality in paints, varnishes, and liquors. The fourth application of gravimetric analysis is monitoring toxic solvent migration limits in plastic food packaging. Here are the advantages of gravimetric method. The first one is high precision and accuracy in measuring non-volatile residues. Versatility across different industries and applications. Reliable results for quality control and compliance purpose. Measurement of evaporation. Let me stop by this measurement of evaporation by saying that by giving the third measurement of evaporation, which is called eddy covariance. This is advanced technique used for high precision instruments to measure the exchange of gases between the Earth's surface and the atmosphere, allowing for direct measurement of evaporation rates. The eddy covariance method is particularly valuable because it allows for direct measurements of the exchanges of carbon, water, and heat between the atmosphere, soil, and plants. Let me stop here. My colleague will continue.
I'm called Umhil Clements. I'm the one of the members of Group 2. So let's continue the third measurement of evaporation, which called eddy covariance. Eddy covariance have some techniques used, which called the eddy covariance technique involve the calculating the variance of the vertical wind speed and the fluctuation in the physical quantity being measured to determine the energy and the metal fluxes caused by the turbulence. Other technique of eddy covariance, this method enable the measurement of small fluctuation over the different time scale, hours, days, season, years, and spatial scales ranging from 100 to the 2,000 meters. The technique is being established as the most effective approaches for the studying ecological interaction between terrestrial ecosystem and the atmosphere. Eddy covariance method have some advantage. The first advantage, continuous measurement. The eddy covariance method allow for the automatic and the continuous long-term measurement of evapotranspiration. Second advantage is non-intrusive. It minimizes the interference with the target measurement area. The third advantage of eddy covariance method is called spatial coverage. Equivariance provides the average over transpiration measurement at the mesoscale level. This have the meters between 100 and 1000 meters. The fourth advantage of equivariance is called flexibility. Evapotranspiration can be measured at any time and placed using this method. The other measurement of evaporation is called remote sensing. Satellite-based technology can also be employed to estimate the evaporation over the large area by analyzing surface temperature, humidity level, and other relevant data remotely. How? Here we are going to see how the remote sensing working for evapotranspiration measurement. First, data acquisition. Remote sensing instruments on board satellite or aircraft capture image of the Earth's surface at the various wavelengths, including the visible, infrared, and the thermal bands. Other ways for how remote sensing working for evapotranspiration measurement. It's called land surface temperature. By measuring thermo-infrared radiation emitted by land surface, remote sensing can determine the surface temperature, which are crucial for calculating evapotranspiration rates. Other for how remote sensing working for evapotranspiration measurement is called vegetation indices. Remote sensing can also access the vegetation health and density using indices like NDV, which called Normalized Difference Vegetation Index, which help in estimating transpiration rates. There is another for how remote sensing work for evapotranspiration measurement is called evapotranspiration estimation. Combination temperature data with the vegetation indices or the remote sensing algorithm to calculate the evapotranspiration rate across to the different land close to the types. Here we have the advantage of remote sensing for evapotranspiration measurement. First advantage is called spatial coverage. Remote sensing enables to assessment of evapotranspiration over the large area, providing valuable insights for the region water resources management. The second advantage of remote sensing is called temporal resolution. Regular satellite passes allow for the frequent monitoring of the evapotranspiration dynamic, aiding in the irrigation, scheduling, and drought monitoring. The other advantage is called non-invasive. Unlike direct measurement method that require physical installation on the ground, remote sensing is non-intrusive and can call the data remotely. Here we have the challenges of the remote sensing for evapotranspiration measurement. The first challenge is called calibration and validation. This means ensuring the accuracy of remote sensing deliver evapotranspiration estimates require ground-based validation and calibration effort. The second challenge of remote sensing is called cloud cover. Cloud can obstruct satellite imagery limiting data availability for evapotranspiration calculations during the cloud period. The third challenge of remote sensing is called spectral resolution. This means the spectral resolution of remote sensation may impact the precision of the evaporating estimate the especially complex landscape.
Let's go to the role of evaporation in agriculture. Sorry. Evaporation plays a crucial role in agriculture due to its impact on water availability and soil moisture levels. Understanding evaporation is essential for farmers because irrigation management, that's the first point. Knowing the rate of evaporation helps farmers to optimize irrigation schedule, ensuring that crops receive adequate water without wasteful overwatering. So the second it is about crop health. Proper soil moisture levels supported by controlled evapotranspiration contribute to healthy root system, nutrient uptake, and overall crop productivity. Next one, it is about drought preparedness. By monitoring evapotranspiration data enables farmers to anticipate drought conditions and implement effective water management strategies during dry periods. And the last one is water stress control, whereby monitoring evaporation rates, farmers can adjust watering practices to prevent water stress in the plant by promoting better crop resilience. So let's go on factors affecting evaporation. The factor number one is about temperature. As everyone knows, the high temperature generally leads to increased evaporation rates as more energy is available to convert water into vapors. The second one, it is humidity, where evaporation decreases as relative humidity rises since the air becomes saturated with moisture, limiting further evaporation. Another thing which you cannot put behind it is wind speed, where wind enhances evaporation by carrying away evaporated moisture from surfaces by maintaining lower humidity levels near evaporating surface.
Thank you. My name is Cedric and also I'm group member of Group 2 and we're going to continue with applications of evaporation. First of all, we have desalination, and in this process, evaporation is used in desalination processes where seawater is evaporated, leaving behind salts and impurities, thus providing fresh water. Secondly, we have food industry, where evaporation is employed in food processing to concentrate liquids like fruit juices or milk by removing excess water content. Cooling systems. Here, evaporative cooling system use the principle of evaporation to lower temperatures in buildings or refrigeration units. Here on environmental impact, first of all, we have water cycle. Evaporation is the key component of the water cycle, ensuring continuous circulation of water on Earth. Second, we have climate regulation. Here, the evaporation of water bodies contribute to cloud formation and precipitation, influencing regional climates. We all know that to control climate, we need the rain, so evaporation helps us to create rain. We are going to continue with testing understandings. How does evaporation contribute to the water cycle and what role does it play in maintaining environmental balance? Secondly, as a year 1 student, attend the ecology course and climatology at all. Is evaporation affect ecosystem and biodiversity in different regions around the world? Is that a question you can answer by yourself as you have studied it? Also, the third, simply try to explain the potential consequences of altered evaporation patterns on the agriculture and food globally. Also, you can answer that. As a conclusion, in summary, understanding evaporation is major techniques, agricultural significance, and influencing factors is vital for efficient water management practices in farming operations. And here we have a reference. You can check those links so that you can get those books. Thank you. This is the end of our presentation.